The next section concentrates on universal sets, subsets, and complements of subsets. So we want to be able to use set notation to denote elements, which we did in the first one. Now we're going to talk about subsets and complements. It says if every element in set B is also contained in set A, then B is called a subset of A and is written as B is a subset of A. So they're showing you notation. This is a subset symbol. We've had the element of the subset. That means every element that's in B is also inside of A. And we can look at our Venn diagram here and we can see that B is completely inside of A, and every time you have a circle within a circle, that means B is a subset. Every element that's in B is also in A. The universal set that we talked about last year, the universal set is this rectangular box which includes every element within the rectangular boundary, is the set of all possible elements for the situation. All other sets in this situation are subsets of the universal set. So they're saying that since we have a universal set U, A is completely inside of U, so A is a subset of U, and B is a subset of U. Okay, so they got some more examples here. Suppose A contains 0, 1, 2, 3, 4, 5, 6, 7, 8, and also B is 1, 2, and 3. Because 1 is an element of A, which we see here, and 2 is an element of A, which they're talking about here, and 3 is an element of A, that means B is a subset of C. B is a subset of A. So because all the elements in B are also in A, they are a subset. So basically B is a smaller set of what set A is comprised of. A has 1, 2, and 3 in it, so does B, so B is that subset. The set of elements in the universe that are not elements of set B are called the complement of B. So they just threw out another one. We have subsets, universal sets, and now we have a complement. A complement, a way of thinking of a complement of B, is everything that is not in B. And here's your notation. It's called B prime. In the Venn diagram, the complement of B is all of the shaded regions. So you look at everything that's in the universe that is not in set B, that's going to be in your complement. So it's going to be everything except, in this case, 1, 2, and 3. So it's going to be 0, 4, 5, 6, 7, 8. Those are the ones that we can articulate. Now on the study tip over here, we've got some math symbols, and some of these we've already looked at and I've talked about, but we've got a lot of Greek characters and letters here. E, the epsilon, is an element of. When you see a slash through it, it means it's not an element of, so it doesn't belong in that set. The C is a subset of. The prime is a complement, which means everything that's not in A, but in the universe. And we're also going to have intersections and unions. Intersections mean they have to be in both A and B, and a union says it has to be in set A or B, and we're going to come across some of those here in a little bit. Okay, so let's look at example 2. Identify subsets and complements of sets. So they give us a universe, and then sets A, B, C, and D, and E. State whether B is a subset of A. If B is a subset of A, that means every element in B, and B is 5 and 7, must also be in set A. So I want to see if 5 and 7 are also in A. They are. Oops, that's the universe. I got to get in A. 5 and 7, which they are. So because 5 and 7 are inside of A, B is a subset of A. So that is true. As long as A houses all the members of B, it will be a subset. So B is a subset of A. Question B. State whether E is a subset of D. Okay, so E is a set 6 and 3. D is a set 2 and 3. So if E is going to be a subset of D, that means every element in E must also be in D. Well, 3 is in there, but 6 is not. So because 6 is not, E is not a subset. So a lot of times what they'll do is they'll say E is not a subset of D. That would be more true. Letter C. Find the complement of A. And remember this notation, A prime means everything that's in the universe but not in A. So we want everything in the universe that's not in A. So we want to eliminate anything that's in A. So get rid of the 1, get rid of the 4, get rid of the 5, get rid of the 7, get rid of the 8, get rid of the 9. And now the A prime complement of A would be the set of those things in the universe that are not in A that are still standing. 0, 2, 3, 6. That is your complement. Everything in A, everything in the universe is not in set A. And find the complement of D. So giving us another practice set. The complement of D. Take the universe, strike out anything that's in D. We want to omit anything that's in D and everything that's in the universe that's not in D. So it's going to be a pretty good list. 0, 1, then 4, 5, 6, 7, 8, 9. Okay, so in this part of the lesson, we're learning about complements and subsets in the universal set. And also we got to take a look at some of these and probably get into some information on intersections and subsets here shortly.